Hello everyone, my name is Karan Mashru. Welcome to this video. In this video, we are going to look at the solution of the problem, that is Eulerian circuit and path. First of all, let us start by understanding the question. What does question say? An Eulerian path is a path in graph that visits every edge exactly once and it starts and ends up at different vertices. Okay, this should be vertices. So it is a path that visits every edge present in the graph. Okay, it does not mention every vertex. Okay, it visits every edge exactly once. An Eulerian circuit is a Eulerian path which starts and ends on the same vertex. So what will be Eulerian circuit? It will be a path which visits every edge exactly once and starts and ends on the same vertex. Given undirected acyclic graph with V nodes and E edges with adjacency list ADJ, return 2 if the graph contains an Eulerian circuit, else if the graph contains a Eulerian path, return 1, otherwise return 0. So if there is Eulerian circuit, then you need to return 2. If the graph has Eulerian path, you need to return 1, otherwise you need to return 0. Okay, now there is a bit contradicting, because if there is a Eulerian circuit present in the graph, then it will be a cycle only, right? But that's okay. Let's neglect that part, acyclic. So if we look at this, then this is a Eulerian circuit, because I can go from 0 to 2, 2 to 1 and 1 to 0. It will visit all the edges exactly once and it will start and end on the same vertex. So I'll return 2. Now if I look in this, if I start from 1, I'll go to 0, and from 0 I'll go to 2. So this will be a Eulerian path, because it will visit every edge exactly once and it will start and end on different vertices. So I'll return 1. You don't need to read or print anything. Your task is to complete the function is Euler circuit, which takes number of vertices in the graph denoted as V and adjacency list of graph denoted as AGJ, and returns 2 if graph contains Eulerian circuit, else if graph contains an Eulerian path, it returns 1, otherwise it will return 0. The expected time complexity is big O of V plus E, where E is the number of edges in the graph and the expected space complexity is big O of V. So now if we think about solving this problem, then see, if our graph is having Eulerian circuit, okay, then we need to return what? We need to return 2. If it contains Eulerian path, then we need to return 1, and in all the other cases we need to return what? 0. Now understand one thing. What does mean? It means to have a Eulerian circuit, it means that there exists a path such that it ends and starts on the same vertex and it covers all the edges exactly once. Okay, so there is one possibility. Let's say you have 5 number of nodes, okay, 0 to 4. So this is 0 number node, this is, let's say, second number node, this is 4th number node, this is, let's say, first number node, and this is, let's say, third number node. So this is the possibility. This is a Eulerian circuit. Why? Because you can start from any vertex. Let's say you start from 2. So you went to 2 from 2 to 4, 4 to 1, 1 to 3, 3 to 0, and 0 to 2. So you visited every edge exactly once and you started and ended on the same vertex. Please remember, if there was a branch other than this, let's say here is one more, then this would never become a Eulerian circuit. Okay, even if it now it is like this. Why? Because you will not visit every edge exactly once. For example, you started at 2, then you went to 4, then 1, then 3, then 0, then 2. Okay, now let's say you went to 5, then to 4, and then to 2. So you started and ended on the same vertex, but you visited this edge twice. So this is not a Eulerian circuit. Okay, so we need to take care of that. So one possibility is this. Can we think of some other possibility? Yes, this is kind of an edge case. What? In order to find a Eulerian circuit, see, one more possibility is, let's say you have 6 number of nodes from 0 to 5, then 0, 2, let's say 4, 1. Okay, and let's say this is 3, and let's say this is 5. This is also a Eulerian circuit. Why? Because from 0 I can go to 2, from 2 I can go to 4, from 4 I can go to 1, and from 1 I can go to 0. Right? So I will start and end on the same vertex, and every edge will be visited exactly once, every edge present in the graph. So this is also contains a Eulerian circuit. So here also I will return 2, here also I will return 2. So these are the two cases for this. How will we do Eulerian path? So basically it will not form a cycle, but there will not be any branch. It would be a straight path. Okay, so for example, if I have, let's say, 0, 1, 2, 3, 4. So this is a Eulerian path. Now as soon as I put a branch, okay, a multiple branch, so what will happen? See, let's say I start from 0. From 0 I go to 1, from 1 I go to 2, from 2 I go to 3, from 3 I go to 4. Now in order to visit this edge, I need to come back, and when I come back, I will visit this edge twice. So it will not be a Eulerian path. In Eulerian path, every edge will be visited exactly once, and we start and end on different vertices. Okay, so if it is of this form, then it is a Eulerian path. Okay, there is this case. Okay, we will return 1. And what can be other case like this, right? So what can be other case of Eulerian path? Let's say 0, 2, 4. Okay, let's say v is equals to 5. There are 5 vertices from 0 to 4. So it is like this, 1 and 3. So these two are individual. You can start from 0, and at 4 you will visit every edge exactly once, and you will start and end on different vertices. So in this case also we will return 1. Okay, and in all the other cases we will return 0. So in these two cases we have Eulerian circuit, will return 2. In these two cases we have Eulerian path, will return 1, and in all the other cases we will return 0. Now how will we implement it? See, what is the degree of all the vertices here? Degree is 2. It means how many edges are connected to that vertex. So this also has degree 2, 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 and all the vertices have degree 2. Here if I look, this has degree 2, this has degree 2, this has degree 2, and this has degree 2. This has degree 0, and this has degree 0. Okay, so if I can say a number of vertices with a 2 degree plus number of vertices with 0 degree is equals to V, then in that case I have a Eulerian circuit. Okay, what will be this? Here all the vertices in between will have degree 2, and the end vertices will have degree 1. Okay, so all the vertices in between will have degree 2. Similarly, here the vertice in between will have degree 2, end vertice will have degree 1, and these vertices will have degree 0. So if number of vertices with degree 1 is 2, and number of vertices with degree 2 plus degree 0, number of vertices with degree 1 is 2, that is the end vertices on the Eulerian path, and number of vertices with degree 2 plus number of vertices with degree 0 is equal to V minus 2, because 2 are covered here. Okay, then in this case we have Eulerian path, and in all the other cases we will return 0. Now let's look at its actual implementation. So let's look at the actual implementation. So I have taken one degree array in which I will basically store the degree of each vertex by seeing the adjacency list. Then I have taken one variable 2 which will store the number of vertices in the graph with degree 2. I have taken one variable 1 which will store the number of vertices in the graph with degree 1, and I have taken one variable 0 which will store the number of vertices in the graph with degree 0. I have initialized all the degrees as 0. Then I have traversed for all the vertices. I have traversed the adjacency list, and whatever be the x in the adjacency list, I have counted its degree x plus plus. Okay, so basically let's say in the adjacency list of I there is some value j. Okay, then I will say degree of j plus plus, right? So degree of j will increase. Now this is a edge between I and j, right? So degree of I should also increase. When it will increase? When we will traverse the adjacency list of j. In that somewhere it will be I, and during that time degree of I will increase. Okay, so basically we will traverse the adjacency list and make degree of x plus plus. X are all the elements present in different adjacency list. Then I will traverse all the vertices after counting the degree. If the degree of a particular vertex is 2, then I will say 2 plus plus. If it is 1, I will say 1 plus plus. If it is 0, I will say 0 plus plus. Finally, if number of vertices with degree 2 plus number of vertices with degree 0 is equals to V, it is a Eulerian circuit. If number of vertices with degree 1 is 2 and number of vertices with degree 2 plus degree 0 is V minus 2, it is a Eulerian path, and in all the other cases we will return 0. What will be the time complexity? If I look here, we have one for loop of this will basically traverse all the edges, so big O of E plus this is the size of the number of vertices, so big O of V plus E. And what will be the auxiliary space? You see here I have taken this array of size V, so it will be big O of V. Now let's submit this code. So let's submit it. Okay, so we have solved this question successfully.